$48. So in part A on number 48, discussing again these reading rates of 6th graders, does it ask us to find a probability? Does it ask us to find a proportion? Does it ask us to find a percentile rank? Does it say what is the percentile rank? No. It gives us a percentile rank. So this problem has given us the percentile rank. They want us to figure out what is the reading rate associated with this particular percentile rank. So the idea here is that they actually want us to go backwards. They've given us the area or the probability that they want. We need to figure out what value in this scenario, the reading rate, applies to that particular area. Now, why would someone care about this? Well, if you're down at the elementary school, middle school, and you're trying to set up reading groups, you might want to figure out who the top 10% or the lower 90% of readers are, so that way you can divide them up amongst the different classes. Or maybe you want to set up classes so you have all of your strong readers together, all your medium readers together, all your weak readers together, so that you can instruct them appropriately. So basically what they're asking us to do is go backwards. So we're going to talk now about how you can use the normal distribution when you're given probabilities or areas to actually figure out values within your population. Now we're not going to start here, real world and whatnot. We're going to take it back to the standard normal curve to start. That's where we started when we did probabilities. Make stuff a little bit easier. What is the case, or what is true of the standard normal curve? Mean is 0. Standard deviation is 1. So go ahead and find your graph paper or create for yourself a normal distribution with a mean of 0 and a standard deviation of 1. A new one? All right, so we're going to start off, like I said, with the very basic situation of the standard normal curve. So let's take a look at number 13 there on page 378. And 13 says they want us to find the z-score such that the area under the standard normal curve to its left is 0.1. So essentially what they're asking us to do is to locate some point along this x-axis. The area to the left that I will color is going to be 1. Now what I'm going to start off doing is just giving myself an estimate here of where I think that might be. Okay? Obviously it's not going to be perfectly accurate, it's just an estimation. But let's make our estimation intelligent. What is the area to the left of 0? 50%, 0.5 is the area to the left of 0. So I know that 0.1 is going to be somewhere to the left of 0. It's probably going to be fairly close towards the end to have, an area of 0.1. So I'm going to go ahead and estimate somewhere in here, I don't know, like there. Again, I don't know where exactly it needs to end. That's what I'm going to find. But I know that I need an area of 0.1 to the left.
Oh, so it's like literally just 0.1?
Mm-hmm. What's the very problem?
No, I'm confused.
Wow.
If it was 0.1 though, would they start before the 0?
Remember, it's an area of 0.1. We want this area to be 0.1. We don't know where it goes along here. We're trying to find.
Didn't we cover, you covered 3 and 2.
Right. because from here over is half of the area. I need only 0.1 of the area.
So you're not looking for the exact value.
Right, I'm going to find the exact value along here where the line should be, but I know that I need this green to be 0.1. So I've only colored in about 0.1, 10% of my graph is what I'm looking for.
Okay.
Now, if you consider what we have been doing, normally they give us a z-score and say, hey, find the area, find the probability to the left of a particular z-score. At that point, once we made our graph, where would we go to find that area? Table. So we're going to need our table. So go ahead and pull that out. And of course, then we would have the z-score. So on our table, we'd be able to look at the z-score, find it on the little left-hand side. Then we'd be able to follow it over into the chart, into the big sea of numbers, and pull out the area that represented that z-score. Well, we need to go backwards. We need to have an area that's 0.1. We need to figure out what z-score that corresponds to. So what we need to do is play a little Where's Waldo, a little hide and seek, if you will. We need to look over this table and all of those sea of numbers and find an area that's close to 0.1. Now, I can narrow my focus of my search. I know it's probably going to be somewhere here in the -1 range. So I can tend to focus my area here on that part of the table. So we want to take a look all over the sea of numbers and find a number that is closest to 0.1. If you find something that you think is close to 0.1, shout it out. I'll write it down. I want to know the areas that you're finding that are close. I want to know the areas that you're finding that are close. So point blah 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 blah. Okay, 0.1003. Other things that are close, perhaps is our 0.999 number that might be close to 0.1.
Yes.
All we are doing is searching this sea of numbers to find a number that is close to 0.1.
0.0985.
0.0985.
0.1020.
Okay.
0.1038.
Okay. That is going to be more than that, so I know that one's not going to be any closer. Anything else in 0.99 range, 0.099 range, maybe? 0.098, the closest. Okay. So we have these three options. Which of those three is actually closest to 0.1? Okay, so this one is the closest. So what z-score applies or coincides with 0.1003? Okay, so this matches up. -1.28. So that means that really on our graph, which should have been maybe right in there, tack on a little extra, but the z-score that applies to 0.1 is -1.28.
So you're looking for what's closest.
What is the value they gave us?
There's a closest z-score here, and then you take the z-score. Okay. So you have to estimate first.
And the reason we estimate first is so we have a focus. We don't want to be searching that whole table for 0.1. We know it's going to be somewhere in this area. This helps us narrow in our focus.
So how do you know where to estimate?
Well, I know that halfway is at the 0, so I know it's going to be less than halfway. Beyond that, you just kind of guess. Other questions? Find where it's all now?
So it doesn't start from the 0 in the middle, it starts from the 0 at the end?
Because in this case, they asked us for an area to the left, 3.1.
Okay, that's what I wasn't understanding.
Other questions?
I'm just trying to figure out
So these numbers came from the table,
Right.
so they're just values that are here somewhere. Are you on table 5? Other questions before we try another one?
Yes. Yes, please.
All right, so let's try number 14. 14 says they want to find the C-score, such the area seen on the curve to the left is 0.2. So now we want to find 0.2. Obviously, we know from our last problem that 0.1 was right about here, so of course 0.2 is going to be a little more to the right.
So can I estimate before I write my numbers on the board?
Don't understand.
So like, you know how you said that the 0 at the bottom doesn't start 0 with my Z-score number that they gave me? 0 would be from left or right?
As far as the area is concerned, yes.
Yeah. So if I estimate, then write my numbers on the...
Your numbers are always going to be this.
Okay, I know that, but I mean like... Never mind.
Sorry? Because the problem said find the C-score so that it's to the left. No left. So, we want to estimate a 0.2. I don't know where that's going to be, but it should be, a little further to the right than what we had the 0.1. Obviously, it's not going to clear over the 0 because that's 0.5. So now, we want to start searching the sea of numbers. Again, we know it's going to be somewhere above 0 on our table. Probably going to be somewhere between 0 and -1. 867, I heard a 0.2 something.
0.205.
Okay. Anything else? Maybe a 0.199 or something like that?
1977.
1997, that was a pretty good year.
No, 1977.
Oh, 1977. Oh, 1977.
Oh, I was gonna say 1841, but I have a 1. I think 2.00.
So you have 2.2000. Right. Anything else close 0.2? So which one is our winner?
205.
All right, so what Z-score corresponds to 0.2005?
-0.85.
What?
84.
84.
Yeah.
84. So that is a Z-score of -0.84. So actually, it probably should be a little closer here to the 1. -1 was my estimate, but yeah, it's an estimate. Yes, sir? Say that again? Because this number is closest to 0.2. Of all the ones that are available. Other questions? Isn't that fun?
Understanding the whole guessing.
That was hard. Now, keep in mind, as we saw with the reading rate, there might be a reason for that. This actually is something that happens very often in the real world. Think about going to a restaurant. Certain restaurants have, special menus for people who are weed or people who are super old. Right? They might pay a different rate. They might get more or less food. You just select on the special menu, all of that kind of stuff. And so the way that they determine those ages is oftentimes based on using the normal distribution. They look at all of the ages of all of the people that come into the restaurant. They decide, do I want to have just 5%, just 2% that I'm giving these cheaper menus to? And so then they figure out what age that represents. So there is a good use of that of this process. Now that said, I'm not sure that all those people would enjoy playing seek and find. I think it's fun. Well, it's not cool, but not everybody's going to agree with that. And so, in order to hasten this process, there is technology that can help us out with this. So, we're going to look at how we do that. Now, let's first keep in mind, what are we trying to do? We are trying to use the normal distribution, but in the opposite way. You might also refer to that as an inverse way. Okay? So, if you go to your calculator, get yourself a calculator page, and we will learn how to use the inverse of the normal distribution so that we can find these values given areas rather than have to play where's Waldo. Alright, so it's actually located in the same place where we were at for binomial and Poisson. So if you go to the probability distribution menu, you'll notice sitting there right in front of you is something called inverse normal. So that is the thing that we want. Now, keep in mind that when they're talking about an area, they are talking about an area to the left. So just like our table only does things to the left, the calculator also only understands things to the left. So if we redo, let's say number 13, where we started, they want an area to the left of 0.1. So we put in 0.1. Probability distribution menu, inverse normal. Does our distribution have a mean of 0? Standard deviation of 1?
Yeah.
We don't have to change any of that. We just put in our area
Oh,
and press enter.
well, look at that. Now I don't have to guess.
So we were very close in our estimation. We weren't that far off of negative 1.28155. But exactly 0.1 is at negative 1.28155.
So with this, you don't have to estimate.
We'll still do a graph and estimate where we get
So this whole estimate, why we estimate it?
so that we have an idea of how much we're looking at. It will even become more important in a minute. All right, let's try 14. Go ahead and see if you can enter 14, which is 2. Let's see how far off we were on that one. I actually forgot your decimal point. Okay, so again, we were very close to what the actual value is for an area of 0.2. Questions? Now, of course, both of these were left-hand areas. If you look at number 15, it says find the z-score such that the area under the standard curve to the right is 0.25. So, let's go back to our graph. We want to figure out somewhere where we have an area to the right, which is 0.25. So again, I don't know. Here, we want 0.25 to the right.
So my estimate's never going to be right. Like, that's not
Not
what
gonna be exactly.
on.
Now, this is, of course, 0.25 to the right. But our calculator only understands to the left. So what is to the left here, 0.7 of them. So what we're actually going to type in the calculator is 0.75, because that's the one that's to the left of this question.
And then we do the complement, like the
Josh?
100 minus.
Sorry? Can I put a negative 0.25 because you can't have a negative variance? All right, so we're going to go look up 0.75. That should give us the same spot on the graph that we would need for 0.25. That's right. So we would need our graph to be at 0.67449. So that was a pretty good estimate. Maybe over there a little bit, but pretty close. Go ahead and try number 16.
I got a question. I like this plus. And it makes it bigger.
Where the time reflects. Well, for the first period is actually.
Okay, what do we just do? Oh.
Well, oh.
You gotta put in point.
Now, see, that's where our estimating helps us, because I got a negative answer. I said, whoa, that ain't right. I just covered in the positive region. So that is how that can be very helpful. So we end up with a 0.39. What we hear? Questions?
Like, if you give us a 30 something, will we have to use it as
The graph can go. Alright, so the last type of problem that we could see, besides being left and right, is the in-between situation. And that's what we see in number 17. 17 says, find the z-score that separates the middle 99% from the area in the tails. So we want to find two places, one place on the left, one place on the right, that's going to stop and start. So we have 99% of the middle, with the little bitty pieces over to the top. So we need to find two spots. So we're going to need to figure out what areas are to the left of all of these two spots in question so that we know what we need to enter for our calculator inverse normal function. So what we need to consider here, first of all, we want a 0.99 here in the center. Well, how much do we have left over? Okay, we have 1% left over in the tails that we don't actually want. It's not going to be part of our middle part. But here's the thing. That 1% is actually divided up between this side over here and this side over here. So how much is actually left in just this little spot right there? Okay? So we know that left over here in the empty space is 0.005. So that actually is the first number I'm going to use in my inverse normal, because that will give me my spot right here. To the left is 0.05, to the right is going to be the starting point of my 99. Questions about that? Correct? Correct.
Wait,
Yes?
what's it called? Like, what are we doing? What is
We're finding the random variable that corresponds to a specific area.
Can you explain that?
Here. So first of all, we figured out what was left over that was not going to be part of our area. So that's 1%. And then we divided that by 2 because there's a little piece over here and there's a little piece over here. Right. Now, the other thing, of course, I need is whatever spot is right here. So I need to figure out what area is to the left of this space so I can figure out where my 99% is going to end. The easiest way to do that is to actually figure out what area is right here. What area do we figure out over here in this tail piece? 0.005. That's to the right, so what do we do to find what's to the left? Oh, like we just did. So the other number I'm going to look up in my calculator is 0.995. And that will give me the two values that represent the starting point of my 99% and the ending point of my 99%. Questions? All right, let's go to our inverse normal. This one is 0.005. So negative 2.58. And then we have our 995 at 2.58.
That's what it is on both sides.
Why did we do what? Why did we do what? Because we need to find a spot here and a spot here. But it's the same because we are chunking it out of the middle. Of course it's the same thing because this graph is symmetric. So if I have 0.05 left over here, that's going to be the same spot as over here. Other questions? Say again. If it's not a symmetric situation, then it's not going to have the same value. All right, let's take a look at number 18. 18, we want to separate the middle 94% from the area in the tails. Yep.
Will we have to lift the homework like these two parts? Each other parts?
It'd be very difficult to do that without your calculator. Now the process that we do in order to actually find these two little area pieces is the same every time. So we subtract, figure out how much we have left over. We divide that by 2 to figure out what's in the tail pieces. And then we can use those numbers to figure out what we need from the calculator. So we start off with the complement of our area. So there's 6% of the area that we're not using to be part of the middle 94. Then we divide that by 2 because of course it's separated between the left tail and the right tail. So we know there's 0.03 left over in that little white space. And there's 0.03 left in that little white space. The next step is the same. Any problems to the middle. So we'll look up the 0.03. That will get us our value over here. This other side, of course, has 0.03 to the right, so we will complement that to figure out what is to the left.
Would it be okay if we just figured out the first one and the second one?
In this case, yes, because you're using the standard normal curve. That won't happen if you're using something that is real world. It will technically be symmetrical, but it'll be very different numbers. So we need to look up our 0.03, that'll get us our left-hand side. We'll look up the 0.97, that will get us our right-hand side. Questions? Thoughts, questions, concerns, issues?
So technically, if both sides go for the range and the same, you just look up one.
You can, and like I said to Josh, that works for the standard normal curve. It's going to be the same number. But if you're looking at something that's real world and your mean is 125, what's going to be less over here is not going to be the same thing. So that is what is, oh my God, I'm going to use the inverse normal. Oh, how did you do that? Inverse normal function, probability distribution menu. Other questions? So let's go back to our original question that we were looking at, which was these reading rates. Number 48 that we were looking at. We have our reading rates for 6th graders. They had a mean of 125. They had a standard deviation of 24. So we have, of course, our graph that looks like that. That was a few days ago. And in question A, they want us to determine where the 90th percentile is for our 6th graders. Now, we've talked about to the left, we've talked about to the right. If we're talking about a percentile, what does that mean to the left, to the right, to the middle? To the left, 90th percentile tells me there's 90% of people that were below, 10% of people that were above. So we want to find somewhere where the area to the left is 90%. I mean, that's, almost the whole graph. So to the left is 0.9. Right, we actually don't even need to complement because it's to the left, no extra work is required. So we just need to go to the inverse normal, type in 0.9.
add me and then you lost me real quick.
Now, remember, of course, we have a mean of 125, so we are going to need to change that.
Okay.
We have a standard deviation of 24, because we're not dealing with the standard normal curve anymore.
Okay. Let's see what we're doing. Alright, I can do that.
Sure you know how to answer it?
Okay, no,
About 27.
Okay, which one is it? 125, 125, and then 24, right? Boom.
If you were going to keep it in that regard, you would actually need to find the z-score after you go to the point 9. And the number that you get is the z-score, so that would be your z, and you'd actually be solving the x. Alright, so when we press enter, so 155.757. So if a student reads, at 155, 156, there's probably a little more in there, but, it's an estimate. That would mean that they are at the 90th percentile of 6th grade readers. Questions? All right, let's look at 48B. School psychologist wants to determine reading rates for unusual students. So those who read really fast and those who read really slow. And so they want us to find the middle 95% of our 6th graders. So somewhere in here, we want 95%.
What number is it?
This is B. So once we find the middle 95%, we'll know what is the cutoff point for the slow readers. So if there's someone who reads less than this number, we know that they fall into the slow reader group. And we can figure out if they read very quickly where the cutoff point is for students who read exceptionally well. Now the last one, we just took the number 0.9 and we typed it in the calculator. Can we do that here? No, this is one of these middle ones. So we have to find out what pieces are left over in our table so that we know what we need to enter. So we need to start, of course, by complementing. So there's 5% that we're not putting into our readers. But of course, that's divided up over the two ends.
Oh.
And then, of course, we have 0.025 here, so we need to complement that and figure out what we're going to type in. So we get that.
Oh, okay.
72.
But it only tells you one of them.
This one will give us this value, and then this one will give us the upper value.
Oh, that makes sense.
So first we need 0.025. Again, make sure you have the mean of 125 and the standard deviation of 24. And then we have the 975.
172. Hey. I'm on. Mine is saying that the name is there.
Maybe forgot a decimal point or don't have your meaning right, something like
Oh,
that.
mine has 3 numbers in there.
Is that? We did it twice because we have a lower place where we're starting those numbers and ending it. That's from the middle. Yep. I typed in both numbers in right. Because this is what happens, yes. If you look right here, 0.03 and the 0.97 are the same number, they're just opposite signs. The problem is that that's 0 and things are the same numbers as you go out. This is not the same number as you go out. So I go out 125 and I go by 24, it's not going to be the same number on each side. Now, this number, 77.96, is the same distance from the mean as 172.039 is this way, but not the same value. Other questions? All right, so take a few moments to try number 47.